So now that we've done inequalities, we're going to talk about absolute values. So absolute. Okay, so what is an absolute value? Absolute value just means how far away from the origin are you. So if you have a number line here, and let's say I have like 2. How far away is 2 from the origin? Let's see, 2 spaces, so it's 2 away. So the absolute value, how far away am I from the origin? Okay, what about the absolute value of -1? So let's see, here's -1. How far away is -1 from the origin? Just 1. What about the absolute value of -5? So -5 is over here. Now we're looking at this little distance. How far away is it? 5. So hopefully you kind of see the pattern here. The absolute value is just how far away are we from the origin. So how far away are we from 0? So there's 3 types of absolute value equations that we're going to look at. So we're going to go through them. So the first type is if I say the absolute value of a number is equal to another number. And I'm going to erase this A. And I'm going to call it a heart. So let's say the absolute value of heart is equal to A. So kind of as an example over here, if I say that the absolute value of x is equal to 2, I'm saying give me x values where I'm equal to 2. So give me x values where the distance from the origin is 2. Well, definitely 2 over there. That's going to be one of our solutions. But also -2. So kind of think about this picture whenever you see an equal sign. If you want to get rid of the absolute values and set equal, you do 2 things. Set the inside equal to A, and also -A. Just like we did over here. Set x equal to 2 or -2. So let's do a couple of examples with that. Say that the absolute value of x minus 3 is equal to 4. Okay, so this is equal to, so remember I'm thinking numbers that are 4 away from the origin. Well, it's either going to be 4 or -4. So I'll say x minus 3 is 4, or x minus 3 is -4. These are just 2 linear equations, so let's solve by adding 3 to both sides. So I get 7 or -1. Let's try another one. How about 2 times the absolute value of x minus 2 is equal to 8. Well, I don't have my absolute value by itself, so let's kind of manipulate this problem until it is. So if I divide by 2, I get the absolute value of x minus 2 is 4. So in your head, you kind of want to think, here's the origin. I'm looking for stuff that's 4 away. So if I go 4 in each direction, here's 4 and -4. So I'll set the inside equal to 4, and I'll also set the inside equal to -4. Now solve for x by adding 2 to both sides, so I get 6 and -2. So whenever you see the absolute value is equal to a number, to get rid of that absolute value, you're going to say either it's A or it's -A. Let's do one more of these. How about -3 times the absolute value of x plus 2 is equal to 10. So just like we did on the last one, you need to get the absolute value by itself. So I'm going to divide both sides by 3. Oops. I'll get -10 over 3. And then you would say, oh, well, I want to be equal to this. Either the inside is -10/3 or the inside is +10/3. But be careful. This statement says that the absolute value, kind of ignore this for a second, the absolute value of something is a negative value. Is that even possible? So if you go back to that number line, remember here's the origin, is it possible for the distance between the origin and some other number to be negative? So the answer there is no, this can't happen, so there's no solution. So whenever you have that the absolute value is equal to a negative number, you want to say that there is no solution. So the next type of absolute value equation that we're going to look at is, let's say I have the absolute value is less than or equal to, they're treated the same way, a number. So kind of the picture that we want to think in our head. The absolute value of x is less than 2. Now here's my origin. I'm saying give me all the values of x so that the distance between x and the origin is less than 2. Well, here's 2, so it's definitely going to be all of this. Right, not including 2, but everything between 0 and 2, the distance is definitely less than 2. But there's also, if you come over here to negative 2, all of this. This is kind of like saying I start at the origin and have a radius of 2. I want all of the stuff that's less than 2, all the distance is less than 2. So what did we just mark here? You said everything between negative 2 and 2. Same idea applies over here on the left. If you want to get rid of the absolute values, you would set it and bound it between negative a and a. And it's coming from this picture. If you want the absolute value to be less than a number, well then I need to go to the left of 0 that many and to the right of 0 that many. So let's try a couple of these. If I say that the absolute value of 2x minus 3 is less than 7. Remember, I'm thinking that the origin is in the middle, and I'm looking at everything that's going to be to the left 7 units and also to the right 7 units. So I'm going to bound it by negative 7 and 7. Now solve for x. So go back to when we were doing inequalities. To solve for this x, you would first add 3. So I'll get 10 and negative 4. And then lastly, you would divide by 2. And you'll be careful. The rules still apply that if you divide by a negative, you got to flip the inequalities. But I'm dividing by a positive, so I'm okay. But just remember that. So I get x is between negative 2 and 5. So how do we write this? Well, let's write it as an interval. So as an interval, I get negative 2 to 5. I'm using parentheses because it was strictly greater than, not greater than or equal to. How about 2 times the absolute value of x minus 1 is less than or equal to 10. Same thing with equalities. You need to get that absolute value by itself, so let's divide both sides by 2. So I get the absolute value of x minus 1 is less than 5. So I'm looking for everything on the number line where the distance between the origin and that number is less than or equal to 5. So kind of the picture here. Here's my origin. I'm going to go 5 units that way and 5 units that way. So I'll bound it. I either want to be greater than or equal to negative 5 or less than or equal to 5. And then lastly, you want to solve for x. So I'll add 1 to everything. And I get negative 4 is less than or equal to x, which is less than or equal to 6. So what's our solution? Negative 4 to 6, including my endpoints. Okay, so we have equality we've done less than. The third type of absolute value is when I have greater than or equal to a number. So kind of to the side, let's have a picture we want to think. If I say the absolute value of x is greater than 2, so here's my origin, I'm looking for numbers where the distance between the origin and that number is larger than 2. We'll see. There's 2, so definitely all of that. Everything that's above 2 is going to be further than 2 away from the origin. But also, all of this stuff down here. So it kind of mirrors itself. You can kind of flip the number line across itself. I'm looking for everything greater than 2, but then also everything less than negative 2. So my answer would be negative infinity to 2, negative 2, together with 2 to infinity. Now on the left, how are you going to solve this? You're going to do what we just did. You're either going to say it's greater than a, or it's less than or equal to negative a. So that's, here's my greater than a, here's my less than or equal to negative a. So for example, 2 times the absolute value of x minus 3 is greater than 5. First thing I'm going to do, get the absolute value by itself. So if I get the absolute value by itself, I get x minus 3, absolute value of x minus 3 greater than 5 over 2. In your head, think this picture. If I'm going to be greater than a number, I have to be at 2 of the extremes. So either x minus 3 is greater than 5 halves, or x minus 3 is less than negative 5 halves. And now I'm going to add 3 to both sides. So let's see, 3 is 6 halves. So if I add 3, I'm going to get 11 halves over here. Same thing, I'm going to add 3 to this side. So if I add 3, I have 6 halves. I have my negative 5 halves plus 6 halves gives me 1 half. Okay, so come up here and let's write our solution. So our solution was everything larger than 11 halves and everything less than 1 half. Now typically when we write this, write the smaller one first. So I'm going to take care of this one first. That says negative infinity to 1 half. Union with everything larger than 11 halves. So I got negative infinity to 1 half, union with 11 halves to infinity. Okay, one more of these. How about 2 minus 3 times the absolute value of x plus 3? And let's say that that is less than or equal to 9. So at first glance, this looks like a less than or equal to problem, so you kind of think that we're going to bound it, but the absolute value is not by itself, so we can't jump to that conclusion. So get the absolute value by itself. So first subtract 2. If I subtract 2, then I get a 7. Now we need to take care of that negative 3, so since it's multiplying here, so there's multiplication between those two, you got to divide. But what happens when you divide by a negative? Well, that means you got to flip the sign. So I have x, the absolute value of x plus 3 is greater than or equal to negative 7/3. Now stop for a second. Think about what this says. This says the distance of something is greater than or equal to a negative number. But isn't that always true? Or isn't it always true that the distance between the origin and any other number is always going to be positive? So since this is always true, we say that the solution is all real numbers, because it's always true. So just to recap here, 3 types of absolute value problems. I have the absolute value of a is equal to a number. Sorry, the absolute value of something is equal to a. The absolute value is less than or equal to a. Or the absolute value is greater than or equal to a. So how do you get rid of the absolute values? Well, in the first one, you say it's equal to a or it's equal to negative a. In the second one, bound it. Bound it below by your negative and above by the positive. And then in the third one, you're going to have 2. Either it's larger than a or it's less than or equal to the negative a. A couple things also to keep in mind. The absolute value is always greater than or equal to 0. It's never negative. So if you get something that is negative, you'd say that you have no solutions. If you get a true statement, then you'd say all real solutions. So these are kind of all the things you need to know about absolute values.